Hi everyone, thank you so much for joining this video. Today's learning objective is to look at the structures of primary and secondary amides. So now we're going to look at amides, and they are a homologous series with a general formula of C double bond O, and then we have a nitrogen. And what goes on the nitrogen depends on whether we have a primary amide or secondary amide. So I'm just going to put two bonds there for now. And amides are the products of reactions of acyl chlorides with ammonia, or amines. So we've seen that when we react ammonia with acyl chlorides in an acylation reaction, we form a primary amide, whereas when we react acyl chlorides with a primary amine, we form an N-substituted amide, or a secondary amide. And amide groups are common in nature. So for example, in proteins, the amine and carboxylic acid groups of amino acids are bonded together to form amide groups. And like amines, we have the existence of primary and secondary amides. So a primary amide would be if we had two hydrogens attached to the nitrogen. So for example, we could have propanamide. So we have CH3, CH2, and then C double bond O, and then NH2. So this is propanamide. And this is our primary amide. And then as an example of a secondary amide, we could have N-methyl ethanamide. So we have CH3, and then C double bond O, and then the nitrogen, and this time we only have one hydrogen, and the other group is a methyl group. And so this is called N-methyl ethanamide. And this is our secondary amide. And how we name it is that we need to use an N because we need to indicate where we're putting our substituent group. So it's on the nitrogen. And then methyl is just telling us what the substituent group is. So it says CH3 here. And we use the prefix eth for the amide because we have two carbons. And this is the same for naming the primary amide because we have three carbons. And so this must be propanamide.